We now cover part 2 of the 26th Philippine Math Olympiad qualifying stage questionnaire. Problem number 1. What is the remainder when 2023 raised to 12 squared is divided by 26? 2023 raised to 12 squared is equal to 2023 raised to 144. So we are finding now the remainder when this number is divided by 26. Now we can easily do this by applying the concept of congruences or modular arithmetic. Now notice first that 26 divides 2023 plus 5, which implies that 2023 is congruent to negative 5 mod 26. Alright, now let's square both sides of this congruence so that we get 2023 squared congruent to negative 5 squared mod 26. Now we have 2023 squared congruent to 25 mod 26. Now since 25 is congruent to negative 1 mod 26, I can just replace the 25 by negative 1. So we have 2023 squared congruent to negative 1 mod 26. Now notice that we need an exponent of 144, so we just need to raise both sides of this congruence to 72. So we have 2023 squared raised to 72 congruent to negative 1 raised to 72 mod 26. And finally we have 2023 raised to 144 congruent to 1 mod 26. So the remainder when 2023 raised to 12 squared is divided by 26 is 1, and the answer is answer choice A. Problem number 2. There are 2024 coins laid out in a row. For some integer x, at least 2/3 of the first x coins are heads, and at least 4/5 of the last x coins are tails. What is the maximum possible value of x? Note that the number of heads of the first x coins is 2/3 x. And then the number of tails of the last x coins is 4/5 x. And note also that the sum of these numbers must not exceed the total number of coins, which is 2024. So we have the inequality 2/3 x plus 4/5 x less than or equal to 2024. Now we must find the largest possible value of x that is divisible by both 3 and 5 that makes this inequality true. Let's combine the terms in the left hand side. We have 2022 over 15x less than or equal to 2024. Then this one is equivalent to x less than or equal to 15 times 2024 all divided by 22. This gives us x less than or equal to 1380. Now the last inequality gives us the range for the possible values of x, but we should choose the largest possible value of x that's divisible by 15, and obviously 1380 is divisible by 15, and so this is the number that we are looking for. So the final answer here is answer choice D. Problem number 3. Find the remainder when the sum 2023 raised to n from n equals 1 to 2023 is divided by 15. Let us first expand the given sum. The given sum is equivalent to 2023 raised to 1 plus 2023 raised to 2 plus 2023 raised to 3 up to 2023 raised to 2023. And then what we will do next is look for some patterns in terms of the remainders of the powers of 2023 when divided by 15. Let's determine first the remainder when 2023 raised to 1 is divided by 15. Obviously, since 15 divides 2025, we can say that 2023 raised to 1 is congruent to negative 2 mod 15. And take note, you can also use here a positive remainder if you want, but I'll just retain the negative number here. Now what if we divide 2023 squared by 15? What's the remainder? You can just square both sides of the first congruence to come up with 2023 squared in the left hand side. And so we have 2023 squared congruent to negative 2 squared, and that's 4. And so we have here 4 mod 15. Now what if we divide 2023 raised to 3 by 15? What's the remainder? You can multiply the first two congruences to come up with 2023 cube, or you can just cube both sides of the first congruence to come up with 2023 cube. So let's just cube the first congruence. So if we cube both sides of the first congruence, we will have 2023 cube congruent to negative 2 raised to 3 mod 15. Negative 2 raised to 3, that's negative 8. So 2023 cube is congruent to negative 8 mod 15. Now, what if we divide 2023 raised to 4 by 15? What's the remainder? You can just square both sides of the second congruence, this one, to come up with 2023 raised to 4. So let's do that. If we square both sides of this second congruence, we will have 2023 raised to 4 congruent to 4 squared, that's 16 mod 15. But 16 is congruent to 1 mod 15, so I can just replace 16 by 1. So I'll erase that and replace it by 1. Now let's just continue the process and see if we can spot a cycle. What if we divide 2023 raised to 5 by 15? Now to come up with 2023 raised to 5, we can just multiply these two, and so 2023 raised to 5 is congruent to negative 32 mod 15. But take note that negative 32 is congruent to negative 2 mod 15. So I can just replace negative 32 by negative 2. Now notice that there is a pattern. The remainders repeat after every fourth term of the sequence. Okay, so if you look at the first four remainders, we have negative 2, 4, negative 8, and 1. And then it goes back to negative 2 in the fifth power. So it means that the next remainder here is 4, and then followed by negative 8, and then by 1. And so, from this observation, we can say that 23 raised to 1 plus 2023 raised to 2 plus 2023 raised to 3 plus 2023 raised to 4 is congruent to negative 2 plus 4 plus negative 8 plus 1 mod 15. So let's get the sum of these four numbers, and that is just 10. So we have here 10 mod 15. And because the remainders repeat after every fourth power, we have that 23 raised to 5 plus 23 raised to 6 plus 23 raised to 7 plus 23 raised to 8 is congruent to 10 mod 15. Now, if we continue this process, we will have here 23 raised to 2017 plus 23 raised to 2018 plus 23 raised to 2019 plus 23 raised to 2020 congruent to 10 mod 15. Okay, so how did I determine that the last line must be this one? You just divide 2020 by 4 since each group consists of 4 terms. Okay, take note that we still have here, after this last line, we should have here 2023 raised to 2021 plus 2023 raised to 2022 plus 2023 raised to 2023. So we have an excess of 3 terms. So the remainder when this excess of 3 terms is divided by 15 is just the sum of negative 2, negative 4, and negative 8, right? So that is just negative 6. So this sum is congruent to negative 6 mod 15, right? Now, if we add all of these congruences, the left hand side is exactly the same as the sum from n equals 1 up to 2023 of 2023 raised to n. And this one is congruent to the sum of all of these copies of 10 plus this last number, which is negative 6. Now let's determine how many copies of 10 we have. Take note, each group consists of 4 terms, so we can just divide 2020 by 4, and that yields 505. So there are 505 copies of 10. So 505 copies. Okay, so this one is congruent to 505 times 10 plus negative 6 mod 15. So this one is 5050 minus 6 mod 15 5044 mod 15. So if you divide 5044 by 15, you get a remainder of 4. So 5044 is congruent to 4 mod 15. So we can just replace this one by 4. And so the remainder when this sum is divided by 15 is 4. And so the final answer here is answer choice A.